I am Shevon Silva. Now I am going to talk about data types. In C supports the following data types among others. Each data type defines constant of that type, and these types includes char, int, double, and float. In char is a single character. A character constant is a single character enclosed by single quotes or apostrophes. Here I'm going to define here as char as C, and I'm going to assign a character 7 here. Then I'm going to display it. For the moment, we do not have to bother about this percentage C symbols, and I simply say get char to hold the string and 0. When I run the program, you can see that number 7 is displayed. And we can also print, for example, ampersand, and I run the program by pressing F5 button. And you can see the number ampersand is printed, and characters which are not printable or which have a special use are represented by a / followed by another character. For example, / new line character represents the new line character, and / single quote character represent the single quote, and also yeah. So I'm going to display the effect of the new line character. You can see the curses after a new line here. If I'm going to now I'm going to display quotation. Yeah, include / quotation, single quote, and again another single quote to enclosing character. And if I run the program, you can see the single quote is displayed, and we can also next data type is int. So I'm going to declare an int variable int I and assign. Here we can simply define int like this, and here the int I is an integer or a whole number. These examples are Here I'm going to first I declare an int, and then I'm going to assign some value. For char character also we can do the same thing. For examples of int can be 25, and I'm going to print a digit here and I, and if I run the program, get an error message. In this case I will rebuild the solution again. Use this semicolon here, and if I run the program, you can see this 25 is displayed. Then integer can also be a value like 0, yeah, and can also be -1, and -2 for 7, and bit larger values like 767. C also allows the use of octal and hexadecimal constants. An octal constant begins with the leading 0, and hexadecimal constant begin with the leading 0x, simple, or 0 x in capital. Uh, for example, the decimal number 59 can be written in octal as 073, and in hexadecimal as OX3B or OX3B capital, or OX capital 3B simple, or OX3B. Here I'm going to show the effects of these things. First, I'm going to print the value for octal. I'm going to assign octal value to integer. It's O73. Then if I see the output, yes, this decimal number 59 is displayed, and now I'm going to print the hexadecimal value. Hexadecimal value for 59 is 3B, and I can either use 3B like this. X and B is simple here, and or I can use B capital, or I can use X capital. I can either use X and B, both are capital. Now I'm going to show you the effects of double data type. Here I'm going to display a double variable, and it's a this is a double precision floating point number. A double constant can be written with a decimal point, um, with an exponent using E or capital E, for both decimal point and exponent. So first I'm going to show you the decimal point assignment for double value, for example 3.56. So if you print with this D value, the output will be something different. The decimal representation of the floating point value, this value is something else. So I simply change it to float, even though we are using double here. There's a small conversion here. Yes, 3.3 is displayed, and we can also have values like -3, -739, and 31. And some values like this is a double value. Yeah, and we can also use LF in some compilers to represent a double value. Yeah, um, and we can use 3.1416, and we can also use the exponent, for example 3736 e minus 1, we got an error because we have to we, we cannot put any space in between, so we have to, it can be a one word. Yes, and also we can use simply for exponent values. Even though this is this E, but we are here basically consider the power of 10, here the power of -1 for in the base of 10, and we can also use the combination of decimal and exponent values, something like 0, 3476, simply E2, and if we run the program, output is displayed as 73. This value is multiplied by 100 here because 10 to power 2, or we can include plus sign here, and now we can change this to capital E. The effect is same. And our next value is next data type is float. I define a variable called f in float. Float is a single precision floating point number. Other languages call this data type real. The float constant is written by adding a suffix f or capital F to a double constant. For example, here I'm going to assign 73 6 as a floating value, and I'm going to use this as float and an F. And even though we can print the single float as a double value, long float. Yes, and we can print it as a float value. Here the compiler represent this as just some kind of conversion problem happened here when we are converting to double, and then if someone want, we can round the value to one decimal place, and or either we can use F capital F float values. Yes, the size of these types depends on the architecture of the particular machine. On many machines, an int variable occupies 2 or 4 bytes, and sometimes 8 bytes in, and a variable of type floats give about 6 or 7 significant different using 4 bytes. Normally, a variable of type double gives about twice the number of significant digits as a variable of type float, and is used when great accuracy is required. The types char, int, and double may be preceded by type qualifiers to alter their meaning. These qualifiers are discussed in later tutorials. A data type commonly used in C is the string. String constant consists of a set of 0 or more characters enclosed by a double quotation marks. For example, I'm going to print a string. Simply, this is a 0 character string. You can see nothing is printed here, and I can include something like A, A, and B, 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 C, and another space. You can see all the characters are printed, and plus is here, the space character is there, and I can print something like pass, I can print something like times 2, or I can print something different, some characters like hash hash sign and percentage sign, another hash, or closing brace, asterisk, and opening brace, underscore plus. You can see the output here, and C does not allow a string constant to be continued on to another line. For example, if we uh, break this string constant to something like this, and if we try to run the program, we get an build error, and here this is missing closing quote, and the closing quote is there, and uh, missing closing quote again, and we get the underscore is undefined, and because we have other characters, and simply if we think like A and BB, and if we break like this again we get some other errors, expected and missing closing quote, and yeah. And in other words, both opening and closing quote must appear in the same line, uh, like this. And however, adjacent string can be concatenated at compile time. Uh, so we can have another adjacent string like this, cc, something like space and cc. Yes, printed, or we can have the same thing in the other line. Basically, this allows a long string to be broken up and placed on more than one line. Uh, something like we can have number of lines, something like this is a long string, and this is the other line, and something like that. Yes, here we didn't have a space character in between these words, that's why these words are combined. And basically when this statement is compiled, the four strings are concatenated, forming one string. In C, a string is stored in an array of characters, Uh, for those familiar with data type Boolean or logical with constant true and false from other languages, it should be noted that C does not have a familiar type, at least not explicitly. Rather, C uses the concept of the value of an expression to denote true or false. An expression can be used in any context where a true or false value is required. Expression is considered true if its value is non-zero and false if its value is zero. For example, if a and b are integer variables, then it's permissible to write like this. So I change our integer variables a, and I declare another variable b, and we discuss about this statement later. And I assign a as a equal 0 and b equal 0, and I can simply write a plus b and print f something like true and the decimal representation of the value of a plus b here. Now I delete it, and or else I simply print false. We will discuss about this if and else statements later, and I use the printf and printf, and after that I print if simply the new line, and I print the value of a plus b also. And if you see the output here, yes, here it's displayed as false 0 because we didn't provide any parameters. We just displayed as false, and the a plus b is 0. Then if I change this value to something like 100, it's evaluated as true. And if I change this value to minus 100, it's again true. Then only the 0 is provided, then it will be evaluated as uh, false. And if you try to include a kind of decimal value here, or double value. In this environment, it's also executed in a C++ environment. So in this program, this statement is executed if a plus b is non-zero or true. If the statement is this statement 2 is executed, this one is if the a plus b is 0 or false. That's the basic concept behind this Boolean evaluation. In latest C standards, Boolean values are available. Um, Thank you very much for going through my presentation.